write down the first numerical problem. A beam of particles of half-life a beam of particles of half-life 2 into 10 to the minus 8 seconds 2 into 10 to the minus 8 seconds in the lab frame with speed 0.96 times the speed of light
तो फ्रेम्स के बाद
with speed 0.96 times the speed of light. How much distance does the beam travel? How much distance does the beam travel before the flux of the beam falls to half of the initial flux?
Sir, can you repeat once again? How much distance does the beam travel after that?
A beam travels before the flux of the beam. The flux of the beam. The flux की spelling है FLUX, flux like electric flux, magnetic flux. Flux of the beam falls to half of the initial flux. I am repeating the question once again. The whole question is: a beam of particles of half-life 2 into 10 to the power minus 8 seconds travels in the laboratory frame with speed 0.96 times the speed of light. How much distance does the beam travel before the flux of the beam falls to half times of the initial flux? So, can you solve it, or should I give you some hint? First you try, then I will give any hint. First you have to try it by your own. If it is not able, then I will tell you. Gaurav, your answer is not even close to the correct one. Please correct. Tarun, you also haven't close to the correct one. No one or ship? It is not. It seems that your concept of time dilation is not correct.
Sir, 76.8 meters.
No, it is. It is not. None of you have got the correct answer. Simply means you do not have understood the concept of time dilation. Anyone else?
सर 1 सेकंड से सॉल्व कर रहे हैं.
Yes, you can take 2 seconds, not 1.
एक्सक्यूज मी सर. सर जो हाफ लाइफ का टाइम दिया आपने सर वो किसके रेस्पेक्ट में लाइफ फ्रेम में कि वो पार्टिकल में?
Everything is given in the problem. So once I tell you with respect to what this time is, then the problem is solved. Then nothing is there.
Yes.
You have to decide. If I tell you which time is to be used there in that formula of time dilation, then it is a simply calculation of a 4th or 5th class student.
Yes.
Sir, 20.57.
Yes, Shikhar, you have got the right one. 20.45 meters. Okay, so let me tell you how you have to solve it. In lab frame means wherever this experiment is being performed, in that frame, that time it is given that the proper time is 2 into 10 to the power
0.2057.
No, it is 20.45 meters. The correct answer is 20.45 meters. So first you have to find the observed time by the ground frame, and the proper time is given. It is 2 into 10 to the minus 8 seconds. So that delta t prime will be delta t means proper time difference divided by under root of 1 minus n square by c square. And when you substitute this value, you will be getting the value of proper time. And you have to use delta t naught as 2 into 10 to the power minus 8 second divided by under root of 1 minus 0.96 times c by c whole square. And on solving this, you will get the observed time for the ground observer. And once you know the time, the speed is given, you have to multiply the speed with the time, and then you will get this 20.45 meters.
उससे 0.2045 आ रहा है. वैसे ही किया.
Correct one is 20.45 meters. Shikhar has already got this answer.
Yes, sir.
सर ऐसे नहीं सोच सकते सर जो उसका हाफ लाइफ है वो उसको सर वो मतलब जैसे इतना ज्यादा स्पीड पे चल रहा है तो उसके में वो लैम्डा फैक्टर से मतलब इंक्रीज हो जाएगा. मतलब वो जो फैक्टर होता है 1/√1 माइनस v स्क्वायर बाई c स्क्वायर उतने से इंक्रीज हो जाएगा क्योंकि इतना तेज चल रहा है.
हाँ, बात तो वही हो गई ना.
हाफ लाइफ जैसे सर जो हाफ लाइफ दिए वो तो ऐसे रेस्ट में आप जैसे दे दिए तो फिर वो उसने फैक्टर से इंक्रीज हो गया तो हाफ लाइफ को हम लोग इंक्रीज कर दिए. उसके बाद नॉर्मली हम लोग डिस्टेंस निकाल लिए.
बस वो वही तो किया ही है, वही किया.
अच्छा अच्छा ठीक है सर.
Exactly नहीं किया हमने. जो
तो सर
half life value क्या है?
20.57 आ रहा है सर. 20.57 आ रहा है.
नहीं, 20.45 है जो मेरे पास इसका सॉल्व है. ठीक है, वो ठीक है. वो राउंडिंग ऑफ अंडर रूट में जो टर्म है उसको राउंडिंग ऑफ के वजह से हो सकता है.
हाफ लाइफ वैल्यू क्या है?
2 into 10 to the power minus 8 second given है. के रिस्पेक्ट में जब निकालेंगे इट इज 7.1 into 10 to the power minus 8 seconds.
सर अगर इस सवाल को अगर सर बीम के प्लेन में करें तो सर इसमें स्पेस कॉन्ट्रैक्शन और टाइम दोनों यूज करके आएगा क्या आंसर?
देखो जब हम बीम के फ्रेम में करेंगे तो कुछ नहीं आएगा, ठीक है, तब तो वो 2 into 10 to the power minus 8 सेकंड ही रहेगा, स्पीड जो दी है वो रहेगी, ठीक है। स्पीड बीम सब तो स्पीड को रेस्ट पे हो गया ना अगर बीम के फ्रेम में ऑब्जर्व करेंगे
तो सर स्पेस कॉन्ट्रैक्ट होगा ना?
नहीं, जब बीम सी पहले फ्रेम ऑफ रेफरेंस डिसाइड करना है। यू टोल्ड दैट यू आर गोइंग टू परफॉर्म दिस एक्सपेरिमेंट विद रेफरेंस टू द बीम फ्रेम, so with respect to the beam these particles are at rest.
Yes sir.
So time dilation will not work there. Time dilation will work only for the observer with respect to whom these particle or this beam is moving. He will observe that time at a time.
Okay sir, ठीक है।
Okay, so everyone has got the correct answer and its solution.
Yes sir.
Delta t prime is delta t naught divided by under root of 1 minus u square by c square, and you have to use delta t naught as 2 into 10 to the power minus 8 second, and then you will get the observed time observed time for the ground frame observer as 7.1 into 10 to the power minus 8 seconds.
चलो 5.6 into 10 to the power minus 9 आती है।
तो आप एक बार सॉल्व ही करके दिखा दीजिए, मतलब सब।
अच्छा ठीक, ओके। So this delta t is delta t naught divided by under root of u square by c square. So you have to put it as 0.2 into 10 to the power minus 8 under root of 1 minus 0.96 times c divided by c whole square, and this on solving will give you 7.1 into 10 to the power minus 8 second. Now you know the time, so that distance traveled will be simply velocity into this time.
सर वही हम लोग 7.143 ले रहे थे, इसीलिए वो फैक्टर ज्यादा आ जा रहा था।
ठीक है ना? Okay, so 0.96 times c into delta t is 7.1 10 to the power minus 8. So this on solving will give you 20.45 meters. Okay.
हाँ सर, हम लोगों ने उसको 7.143 लिया था, इसकी वजह से वो 20.57 आ रहा था।
7.1 को क्या लिया था?
7.143 ले रखा था, मतलब पूरा उसको 3 प्लेसेस तक लिया था।
That's why it is 57. ठीक है।
Yes, sir.
तो ठीक है, ये सभी को समझ आ गया?
Yes, sir.
You should be. You have got the correct one. Okay, write down the next problem. An experimenter observes a radioactive atom. An experimenter observes a radioactive atom moving with a velocity of 1/4 of c moving with a velocity of 1/4 of c.
सर रिपीट कर दीजिए.
An experimenter observes a radioactive atom moving with a velocity of 1/4 of velocity of light, emits a beta particle which has a velocity of 0.9 c, which has a velocity of 0.9 c relative to the atom in the direction of its motion. Relative to the atom in the direction of motion. What is the velocity of the beta particle as observed by the experimenter? What is the velocity of the beta particle as observed by the experimenter? Okay, please turn on your captions so that it will be visible on your screen, whatever I am saying. I am repeating the question once again. Please turn on your captions. Okay, so I am repeating the question once again. An experimenter observes a radioactive atom moving with velocity 1/4 of the velocity of light, emits a beta particle. It not emits, it is emits a beta particle which moves with a velocity of 0.9 times c and propagates in the direction of motion. What would be the velocity of the beta particle as observed by the experimenter? Someone has got the answer? No, Tarun, it's not C. Not so easy.
कंजर्वेशन ऑफ मोमेंटम लगाना पड़ेगा क्या?
That you have to think. If I tell you the formula, then again it will be a work of a class 4th, 5th student.
So 0.277.
No, Yasir. It's too far from the correct one. And we have studied this concept very recent.
सर 0.93 c.
Yes, Surya Pratap. Absolutely. It is 0.94 times c. Okay, 3
So ux prime. Ux prime plus u upon 1 plus ux prime upon c square 1.
Yes. You have to use the concept of relativistic velocity addition formula.
सर उससे 0.277 ही आ रहा है.
नहीं, please check. It is 0.94 times c. ले गए रामगोपाल जी. आया किसी का कुछ आंसर?
यस सर 2.69 c.
2.69. It is 0.94 times c.
So 0.938.
Yes, it is. 0.98. So yes,
आगे
there
बढ़ना
was was getting 2 point something.
सर ऊपर ऐड गलत किया था 0.25 और 0.9 को.
Yes, that's right. Abhinav Singh.
Yes sir. Yes sir, I'm trying. Sir, I'm trying.
Okay, Abhinav. Adarsh.
Yes sir, got the answer.
Okay, Aditya. Aditya. Astha. Achans. Alu.
Yes sir.
Have you got the answer?
Yes sir.
Okay, Akhand.
सर बीटा पार्टिकल की सर स्पीड 0.96 है सी है या सर 0.9
0.9 C.
ओके सर, हमने वैल्यू यस सर आगे.
Okay, so everyone has got the answer?
Yes, sir.
Anyone who is in doubt or is not able to solve this problem?
Yes sir. Yes sir, got done.
Yes, Akansh?
सर नहीं आ रहा.
नहीं आ रहा. Okay.
सर एक बार प्लीज बता दीजिए, इसमें डाउट हो रहा है, समझ नहीं आ रहा.
Okay, Shruti. So, please revise that concept of velocity addition formula. See,
सर 0.5 कौन आ रहा है वेलोसिटी ऑफ सी
नहीं
सर वेलोसिटी ऑफ बीटा पर
0.9.
ओके सर
देखो ये जो प्रॉब्लम है ना, you just have to compare it with the problem that I have given you as an assignment. That there was a spaceship and it was that spaceship was moving with some velocity with respect to ground observer, and there was another toy car which was moving inside that spaceship, and we know the velocity of that spaceship, that toy car with respect to spaceship. And now we have to find the velocity of that toy car with respect to ground. It was a problem that I have given you in your assignment, and we have solved that problem on your next turn. So you have to relate this problem. Exactly, it is analogous to that thing. So here there is some experimenter. So that experimenter is sitting on the ground, and he is observing that some radioactive particle is moving. Okay, it means that radioactive particle it is analogous to the spaceship. And just like we know the velocity of we knew the velocity of spaceship, so we knew here the velocity of that radioactive atom with respect to the experimenter. Okay. Now I have in that problem we had a toy car which was moving with certain velocity, and that velocity was known with respect to spaceship frame. So in the same way here there is this radioactive atom emits a beta particle. That beta particle is analogous to that toy car. So that beta particle moves with velocity 0.9 c in the direction of the motion of radioactive particle, in the same way that the toy car was moving in the direction of propagation of spaceship. So in that problem we had to find the velocity of that spaceship with respect to the ground frame. Here we have to find the velocity of that beta particle, emitted beta particle from that radioactive atom with respect to the experimenter who is sitting on the ground. Is it clear or not?
Yes sir.
Yes sir.
हाँ सर, एनालॉजी समझ आ रही है.
अभी एनालॉजी समझ में आई ना, and this problem we have already solved. अब आप लोग ट्राई करो.
सर आ रहा है 0.93 टाइम्स वेलोसिटी ऑफ लाइट।
ओके, जिन लोग को अभी नहीं आया था वो भी ट्राई करके मुझे बताया आया कि नहीं आया।
खुशबू खुशबू अरे वही से बुलाई कौन। हम्म 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 जाओ 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 जाओ। कहीं हिटलर बन के जाओ। हाँ बहुत सही है।
So attendance, please. Roll number 1.
Present, sir.
I'm using the latest roll numbers, revised roll numbers of everyone. Okay. Everyone know your means fresh roll number.
यस सर।
Okay. Roll number 2,
Present, sir.
3,
नेबुआ है
4,
Present, sir.
प्रेजेंट सर।
नेबुआ
5,
नेबुआ
प्रेजेंट सर।
6,
Present, sir.
7,
Present, sir.
8, Anuj, 9,
9% sir.
10,
Present, sir.
11,
प्रेजेंट सर।
12, 13, 14,
Present, sir.
Aditya Trivedi, 13, 14, 14, 15,
Present, sir.
16,
Present, sir.
17, 18,
प्रेजेंट सर।
19,
प्रेजेंट सर।
20, 21, 21, 22,
Present, sir.
23,
Present, sir.
24,
प्रेजेंट सर।
25,
प्रेजेंट सर।
26, 27, 28,
21 प्रेजेंट है, उसने मैसेज किया।
Which one? 20?
21 सर, ऑरेंज है सर।
21.
present sir.
29,
Present sir, present.
30, 31,
Sir, 31 present.
32.
Present sir, 32 present.
Okay, noted. 33,